Alright, hello everyone, good evening. Okay, so I hope we are ready for the second lap. Let's go. Let's go. All right, so yeah. Please let's join up. Let's join up. Let's join up so we can drive. Okay. Okay, so quickly, I don't know if Steph is here. I don't know who else. Those that asked for, I think I should quickly go to integration by parts. Then before coming back to that, integration by partial fraction, whichever one. Where is my distance? Whichever one. Okay, so I'm giving us a few minutes to join up so we can run together. So we can move together. Okay. This I think is the old one. Looking for the new one. Which I suppose is not here. Okay. Hello, Lisa. Yeah, you're welcome back. My good fan. You are the good fan. Don't mind Samuel and the rest of them. Don't mind them. Okay, I'm trying to bring up something on my integration notes. Let's try to work with that. How many? Yeah. Okay, 6. Okay. Yeah. Okay, so this should be enough. Okay. All right. Okay, so maybe I should write one question on integration by parts. Okay, let's start with this very simple one. We remember this, so I'm looking at by parts now. I'm looking at integration by parts. We remember this person, integral of ln x dx. We remember this one, right? Okay, you don't know where the hashtag is coming. That's to show where you belong. That's to show where you belong. Top fans. Oja former has 25 XP. That's why she's number 1. With Benz, Adolis at 25 SP, and many people 25. Even you have 25, but you're still coming up. Begin to talk. So okay, you even have one self. Okay, let's go up. Abby, let's go on. All right, so you recall what we did here. So you simply will call, remember our integration by parts, u dv equal to uv minus v du. All right, so once you recall this formula, it would always guide you. Okay, so yeah, good evening, Miracle, you're welcome. Okay, so what do we do? Of course, we said that you also remember the abbreviation I gave you. I don't know how many of you still remember the abbreviation I gave you that will guide you in choosing your your u and your dv. Who remembers? Help me, type it if you remember. Type it if you remember. Type it. What's the abbreviation again? Acronym. The acronym I gave you. Type it in the comment section. Let me see. I'm waiting. You have all forgotten. Okay, beautiful. Yeah. Okay, so one person has bailed us. So I said it's Liat or Liati. Okay, yeah, many people are coming to our rescue. Esther, Kamsi, Mimi, Laza, Gift. Correct, this is your own. No. Okay, so where L means logarithm, I means inverse, trig, that's like sine inverse, cos inverse. A means algebraic function like x squared plus 2 10x or whatever. T means trigonometry, that's main trig functions, sine, cosine, tangent, and then E exponential functions. Alright, so so depending on which one. So from here you can actually write this as integral of xo ln x. Don't mind me, but of course it's true. So with this, this will be your u and then x raised to power 0, which is 1. So that's actually what I want to show there. So this is actually 1. So this together with the x will be your dv. So, and that's what we said. So that means our u is equal to ln x and our dv is equal to 1 dx, which you can just call dx. So from here, remember that if you differentiate u, you will now get du to be equal to 1 over x dx, and then from there you make dx the subject, and our dx will be equal to x du, if I am correct. Okay, x du. Okay, so all right, and then okay, and then from here, if you integrate both sides, you will now get our v, which will give us x. Okay, so substituting into this formula, we'll have that integral of ln x dx will be equal to uv, and our u is ln x, so x, which is v times ln x, then minus the integral of v, our v is x, multiplied by dx, which is what did I do now? Okay, I hope I have not made any mistake anywhere. Sorry, come out from there. I hope I have not made a mistake anywhere. What am I supposed to have? When we differentiate ln, what do we get? 1 over x, abi? Yeah. Okay, sorry. Okay, so let me try to see where the mistake is coming from. Okay, so here we have our u is ln x and our dv is this. Who is doing this one? See me see trouble. Okay. All right. So I don't even. Okay. So let me see. So this is going to give me 1 over x dx. Okay. This is actually supposed to be what? Let me write it here. Du over dx is equal to 1 over x. That's the derivative of ln x. And so if you alternate it, so where is the mistake now? Okay. So from here I'm supposed to have where is my formula? It's actually oh god, it's actually the u I'm looking for. So it's the u I'm supposed to substitute here, not this. Sorry about that. I didn't make a mistake, it's just in my substitution. So I didn't need to do this. So it's the u I'm looking for. Okay, thank you. So this is going to be equal to my v, which is x, multiplied by my du, which is 1 over x dx. Okay, thank you. So from here now, I'm going to have this will cancel out this. So I'll have x ln x minus, of course, this will be integral of 1 dx. And of course, if you integrate 1, you will get minus x and then plus c. And that will be our answer. If your own is lagging, remember what I said. Drag the red line to the end of it. To the end of the line. You can use fast forward. If you drag it, then you use fast forward to make sure that it is completely at the end, so that you won't be lagging behind. Guten Tag, yeah, Guten Tag, good afternoon. Wie heißen Sie? How are you doing? Guten Tag. Is Guten Tag good afternoon or good evening? Guten Tag. Guten Morgen is good morning. I've forgotten good afternoon. No. Guten Tag is supposed to be good afternoon. Anyway, need to mind yourself. Okay, so let's move on. So that is the solution for number 1. Okay, so let's move on to another example. And then for the people asking for parts, remember I said you should bring up examples that you'd want us to look at, so that it will make more sense. All right, so let me try to do this one. Integral of x squared ln x dx. Okay, so let's look at that one. That's right. So what do we do there? Okay, so just as we have done here as well, our u will be ln of x, and then our v will be that's the v, sorry, will be equal to x squared dx. Okay, so by the time we now try to simplify, our du will be equal to 1 over x dx, and then if we integrate here, our v alone will be equal to x cubed all over 3. So we'll try to substitute. So our integral of x squared ln x dx will simply be equal to u times v, which is s cubed over 3 times the ln of x. You can see whenever I have ln, I keep ln after your algebra. Okay, it's very important. Then minus the integral of v, which is s cubed over 3 times 1 over x dx, which is your du. That's this guy here. All right, are you still with me? Are you still with me? Make a joyful noise unto the Lord if you are still with me. Okay. All right. Okay. Okay, na me dey play abi. Okay, abi na your course rep. Okay. All right, so let's move on. Okay, so here we are now going to have where is this person saying my head? Where is this? Where did I see? Okay, J. I don't know who the J is again. Hold your head, hold it in your hands, hold your chest in your hands, and manage until we are done. Okay, it's a very simple thing. Don't worry, tomorrow will come and go and you'll be fine. Of course. All right, so this is going to give us x squared over 3 because x will cancel 1x here. So and finally your answer will be x cubed over 3 ln x minus, if we integrate this, we'll get 2 plus 1, which is 3, and then 3 will come down to multiply 3 to give us 9, and then we have plus c, and that's the solution. So would have been way better. Glory to God. Don't worry yourself. It is what it is. It's your Unizik that is the problem. Okay, so in my school we don't used to lock school halls, but here they lock everywhere. So, and I didn't want to go and make quarrels with those security people. So just try to understand. I know that physical class would have been better, but for the stress and everything, let's manage what we have. Monachi, okay? All right. So is there any question here? So as a way of you doing something for me, so from, of course, I gave some of you this thing, this particular note. So help me with the solution of this one. Integral, that's my number 3 after the break. So let me give you integral of let me say integral of 3x cos 2x dx. Is this supposed to be a problem? No, let me give you only x. So from there we can progress. Okay, so everyone help me with that. The integral of 3x cos x dx with respect to s. Quickly. All right, so I'm waiting. Adolisa, thank you. Sam, thank you. Yeah, for the emojis. Let me be giving you people love emoji too, so that it will be entering. Okay, so all right, I'm waiting. I expect everybody to put, okay, yes, after this, I will get to partial integration. After this we get there. Okay, so after this we get there. I didn't get that. Not really. Is it not really saying that we didn't get it, or I should throw more light? Which one? I should throw more light. Okay. Talk am. Omo. Who is this one? Don't try that rubbish here again, no. Thank God you deleted it. I want Kwale here again. Okay, meanwhile, you people should give thumbs up to this video as we are following. please do like the video itself, as in go out from the chat box and like the video, please. Thank you very much. Okay, all right, so please, we fit do plane geometry. Okay, plane geometry, we'll touch equation of circles, equation of maybe equation of straight lines, just a summary, and then equation of circles. Okay, circles is in conic section. You said plane. Anyway, circles are actually supposed to be under plane analytic geometry. Okay, somebody is saying I've forgotten formula. Because which formula? The formula is the same now. See it here now. Integral of u dv is equal to uv minus v du. Okay, so all right, yeah, I'm having some answers here. Okay, so quickly let's do it together because the answers are a bit different. So let's try. All right, so what's going to be our u? Our u will be 3x because we have late, okay, or late if you remove I. So algebra comes before trigonometry. All right. So our u so we let our u to be equal to 3x. So if our u is 3x, so it means that our du will be 3 dx. That's, if you differentiate this, you get 3, then take the x to the other side, so it will get you 3 dx. Then dv is going to be equal to cos x dx, and that will mean that our v alone, integral of cos x, is sine x. Okay, so we will now substitute. So we are going to have u times v, which is 3x sine x, then minus integral of v du. Our v is sine x, then our du is 3 dx, which is this one here. Okay, so yeah, Nexotech, you are welcome. Thank you very much. Okay, so if we open this bracket, we'll now have 3x sine x. So this will be integral of 3 sine x. Of course, you know that 3 can come out of the integral sign if you want. Let me raise this board up a little bit. Permit me. Okay, so from here now, let me even write on this side. So we'll have 3x sine x. So minus, then if you integrate, of course your 3 will come because it's a constant. Then if you integrate sine x, you will now get minus cos x and then plus c. So your answer will be 3x sine x, then plus, that's minus times minus, so you have plus 3 cos x plus c. And I think that's what I got from many of you. Samuel is correct. Pascal, you made a small mistake with your minus sign. Maybe you integrated cos to give you minus sign. No, it is sine only. Then Sam is correct. Steph is correct. Blessing, the same mistake. It should be plus plus. AC, you are correct. Okay, so that's beautiful. Okay, Tony, please check where the mistake is from. There is no square. Okay, so can I move up now? All right, can I move up now? Do I give one more example? Let's see. Okay, just look at this one. The last one, but you'll be the one to do it. Integral of x e 2x dx. Please increase your speed, speed and accuracy. Yeah, Tony. Okay, so everybody, integral of x e to x. So of course your x will still be your u, your e to x will still be your dv. Okay, I'm going up and down because I want to be sure that you are finished with number 3. So I think I can go up now. Okay, Blessing is saying Esther no go dey correct. Okay, now your helper. Choma, mind yourself. Okay, it's alright. It's alright. So let's go. Oh, excuse me. Okay, let's go. Yeah, I've given one more, Brenzo. I've given one more. All right. Yeah, I can see. The one more is here already. Your response is what I'm waiting for. Your response. I want you to do it try as much as possible, and then I can come in and we will finish it up together. Okay. I'm waiting. Okay. Some of it, there may be fractions and all of that. Okay, there may be fractions and all of that. Okay, me, I know what anything. Okay, have you been here since we started this one? Okay, let's do this together because of the kind of answer you'll be getting. I think there will be fractions. So quickly, let's go. So here we choose our u and our v. Remember, we can just use late. You can remove I because we may not necessarily bring in I. Okay, so I'm getting one answer here. All right, so let's look at it together quickly. So what is our u? Our u will be x, and if our u is x, you will get du from it. Your du dx, maybe because I'm jumping that, it's actually supposed to be du dx. So du dx is going to be equal to 1. So you will now cross multiply, so which will give your du as dx times 1 is dx. Then you will try to get your dv. Your dv is the remaining after you remove your u. So and the remaining there is x squared e to x dx. So what do you do to now get your v from there? So you will integrate both sides. I'm seeing some responses. Beautiful. So let's just finish and then we will see. So if you integrate this side, you get v equal to, if you integrate the other side, you have e to x all over 2. How did we get that? If you integrate e, you get e, then you bring down your power and then differentiate that power and use it to divide, which will give you 2. Okay, so let's substitute into the formula. So that's going to give us u times v, which is x, times v, which is e to x over 2. Okay, so with that now you can already see some questions that are, some responses that are not correct. I think Sam has removed his response because it's obvious it was not correct. All right, beautiful. Morgan is still here. That's miracle. At least there is half in his own, so there should be half there. Then minus the integral of our v, which is e to x over 2, then times du, and our du is equal to dx immediately. And this is not supposed to be difficult. So what will you get now? Bring down this e2x over 2 minus, so if you now integrate this, another 2 will come down, and when it multiplies 2 you will get 4. So that will be e2x over 4 and then plus c. So, and as you can see, I think Miracle is correct. Even though, okay, yeah, he is perfectly correct. Even though, okay, there's one mistake. He used plus instead of minus. It's supposed to be minus. So this is supposed to be, so if we put it in his own form, that's 1 over 2. If you bring out 1 over 2, then e2x. In brackets, if you bring out 1 over 2 here, you will have only x left. If you also take away this one, so you have only x left. So here will be x minus, if you bring out this and 1 over 2, only 1 over 2 will be remaining here, and then plus c. So Miracle, just only the minus sign that is the issue. Sam, yeah, this other answer is correct. When you differentiate x is 1. Yes, we got 1. We got 1. Good. Henry Smart is minus, not plus. Is minus. Okay. So quickly, let's go over to, let's take some examples on partial integration. Some people mentioned partial integration. Okay, but before I go to that partial integration, let me quickly review integral of sine to the power of 5, like some people asked me to do. I don't know if Stephanie is here again now. Sam, is Stephanie in this group now? Or Stephanie, if you are here, respond. And Ebube, I think it was 2 of you that were asking about the integral of sine raised to the power of 5. If you are here, please respond so that I will know I'm responding to the people that asked the question, or else we can move on. We can move on to partial fractions. Is Stephanie here? Okay, yeah, you can call her. Let's see. Okay, so while we are waiting for the people that asked the question, so let's look at some examples on partial integral. So integration of partial fraction. So this is going to help us handle 2 things: integration leading to logarithm, and then this integration by partial fraction. Of course, yes, I mean odd powers, but just power 5. Somebody asked for power 5. We are under even power. I've said you should just bother yourself with power 2. Nobody will ask you anything more than power 2, either sine or cosine. Then for odd, you can get more than power 3. You can get power 3, power 5. Last exam they asked power 7. It's possible you can see that. So try your best to also, check power 7. So but we want to do power 5. Then before that, since we are still waiting for the people that asked the question, let's go to partial fractions. That's integration leading to partial fractions. Okay, so under that, I'm going to bring up let's say a number of questions. Let's see this one. Number 1 for this, let's call it integral of 3 minus x, or let me just do integral of or should we do that? Let's just do this one, although this one is not really partial fraction, so let's just do it. Okay, so this one is not really partial fraction because it's very straightforward. So but let's do it, and then we are going to see other examples on partial fractions. Okay, they are active. Okay, all right, no problem. Okay, Steph, you are back. All right. So but before I do that, let me quickly look at this example now. So what do we do here? Now you know that your denominator is difference of two squares, so which you can have as x plus 3 into x minus 3. Okay, and in the numerator you have 3 minus x. So here you can immediately see x minus 3. So you will try to transform this one to look like that denominator. How do you achieve that? If you bring the x forward and bring the 3 backward, so remember to put your dx, so you can immediately see that if I factorize minus in the numerator, I'm going to have x minus 3. Help me confirm that you understood what I just did. Okay, if I factorize x minus 3 here, if you bring it back, minus times x will still give you minus x, and minus times minus 3 will still give you plus 3. So if you understood what I've just done, you just respond with emoji or with a yes. So from here you can now divide. So and that is exactly why I did that, so that this can divide this and there will be 1 here. So you just have integral of minus integral of what did you not understand? What I did there is okay, very straightforward. What we have here is 3 minus x, but in the denominator all the x came first, so I wanted my x to come first. I now brought x to the front, and the x is negative here, so if it comes to the front it will be minus x, then the 3 itself is positive, so it will be plus x. So I decided to bring out minus. If you factorize minus, it will give you x minus 3. Like I said, if you open this bracket, you still get back what you have here originally. Okay, so and why did I do that? So that I will see whether it will allow me cancel anything in the denominator. And of course you can see wisdom, you are the one I'm explaining to now. Okay, of course you can see it has cancelled out, so you just have minus 1 all over x plus 3, then the x. And of course this satisfies the rule of integration that says that if you have integral of f prime of x all over f of x, wisdom, you can respond now if you understood what I just explained. All right, so from here immediately this is satisfied. We said it is equal to the ln of the denominator. Okay, so that means since this is, if you differentiate this denominator you get 1, so your answer is minus ln of that denominator. Okay, and then plus c. So and that is your answer. Okay, Fresh G, you are here now. All right, you are going to pay for this class, Fresh G. So just send them, look for where you can do special thank you, or you can subscribe to membership. Joanne, you are welcome back. So just do something. Okay, beautiful. So let's go on now. So before we continue with another example on partial fraction, let me quickly talk about the sign of power 5, since the people that asked the question are already here. All right, wisdom, that's nice. Okay, so let's go. So what did I say? I said split it into 2, and in splitting it just bring out 1 sign, so leave the remaining 4 here. If it is 7, you leave 6. So here I will now bring out 1. So why am I bringing it? If you have x raised to power 5, it's still the same thing as x raised to power 4 times x. If you multiply the 2, you get back your x raised to power 5. Alright? So now I have sine raised to power 5. I can split it into sine raised to power 4 times sine raised to power 1. This is the same thing as power 1. Alright? So, and they are the same. So why are we doing it? So that we will be able to substitute. Okay, if you don't understand, maybe you just join. How can I subscribe for membership? Just leave this chat group. You will see where they will write join. Click on join. Once you click on that join, it will ask you to just support the group with a payment. You can pay for Trailblazer, you can pay for community builders or whatever. I think the other ones, I think the highest there is 10,000. You can pay 10,000 and God will bless you. Thank you very much. Okay, so let's move on. All right. Done my chain rule. Okay. Anyway, we can touch that as we continue. All right, so what are we going to do here? We are just going to do substitution. Look at the two substitution. Remember that this is the same thing as sine squared, all raised to power 2. So everything you're going to do will land on square. Even if it is power 6, you will square, then raise to power 3, because 2 times 3 will give you 6. If it is 8, you will square. That's why you should always have here to be even, so that you can get 2 out of it. Okay, so assuming it was sine 7, so you split it to sine 6 and sine x, so that this one will now become sine squared all raised to power 3. So that's the idea. Okay, so let's go on. So you can bring down your sine x dx. Now, so at this point, you will now substitute. So you say, now in doing this substitution, I said, when you are dealing with odd power, your u should be the opposite of the trig function you have. If you have sine, let your u be cos. If you have cos, let your u be sine. So let me use red and do this. So my u will be cos. Why are you doing that? So that by the time you differentiate this u, you will get du is equal to minus sine x dx. Okay? So that you will get this person. That's the reason. So that when you differentiate, you get the person here. Assuming it was cos, if you call it sine, if you differentiate, you get cos. And that will give you the person here. That's actually the trick, which is why we substitute that way. Okay, so and then you will bring this, your minus, to the other side. So that means divide both sides by minus, so that this, or multiply both sides by minus, so that here will now become minus du equal to sine x dx. So we are replacing here now with this minus du. And that's not the only substitution you will do there. Remember that your sine squared is equal to 1 minus cos squared. Okay? Alright, so you will now substitute there. So that will give you, if you are still following me, please put your emojis so that I will be sure you are still following. So you have 1 minus cos squared all squared, then multiplied by your sine x dx, which is now equal to minus du. Okay, so and so what's the next thing to do? You will now try to now substitute. Remember that you said let your u be equal to cos. So anywhere you see cos now, you call it u. So here I have cos squared, so that will give me u squared, all squared. Then let this minus sign come to the front, then I will have only the u here. All right, okay. So, and all I said is that since there is power here, you can either integrate this. You know, you can integrate this without having to expand. You can do that. You can do that without having to expand. How will you do it? You bring you use your 2 to divide, and then add 1 to it, use it to divide, and then differentiate what is inside, use it to multiply. The easiest thing is to open the bracket. So let's open the bracket. That's going to give us integral of, when we opened this bracket, I think we got 1 times 1, which is 1, and then minus 2u squared, then plus u raised to power 4. So try to open this bracket by yourself and see what you will get. Then the u here. Okay, and so from there, let me add another board. Okay, so from there we'll now have to now integrate. So minus of, if you integrate 1, you will get u. If you integrate minus 2u, you get minus 2 u raised to power 3 over 3. Then plus, if you integrate u4, you get u5 over 5, and then plus c. So just bring back your u. Your u is cos. So, and then open this bracket. So this minus times u will give you minus u, which is minus cos. Minus times minus is plus, and your u is cos. So you bring in cos 3x over 3. Then minus times plus will give you minus. And that was the correction Sam was giving us. Minus, then who are you? Get out. Then you have cos 5x all over 5, and then plus c. Okay, and that's the answer. Okay, so that's exactly how to get 4 power 5. Okay, so all right. What else were you people asking for? Integration by partial fraction. So maybe I should take just one example on that, and by then it will be 12 midnight, and I'll probably end this class. Let me go down a bit so that you can still see what is there for those that want to write it. I'll probably end this class. Or should I end the class now? He's doing me to end the class now. Should we end the class now so that we'll go and rest? So focus on the things that we have already done. Just revise them very well. Remember your quotient rule. Remember your product rule. Remember your chain rule. Remember your what do you call it, tangent and normal. Remember your stationary points. Remember integration leading to logarithm. We just did that now. Remember integration by partial fraction. It's all 3 a.m. if I punch you, but you can wake me up by 3 a.m. we'll start another class. I'll end by 12. Then you can wake me up by I should not stop. You can wake me up by 3 a.m. we'll start another class. That's not bad. It's just that the whole place is bad. If not, by 3-4 we can start coming to school and do 1 or 2 physical class. Okay, somebody is talking about Esther is talking about piecewise function. So let's just do something on piecewise function. Yes, remember it. If that is what you want me to say, yes, remember piecewise function. Something like this. Let me try to see if I can construct one example on that piecewise function, or let me check if I can see anyone here. Okay, yeah. Okay, yes. Sam, sorry, Precious, you have a question you sent to me. Okay, let's look at this piecewise function quickly and then we look at your question. Sorry. Okay, let f of x be equal to 4x minus 7 for, okay, when x is greater or equal to 3 and equal to x squared. I think this is the same example in that okay, minus 3 when minus 1 is less than x less than or equal to 5, and then finally minus 6x when x is greater than 5. I don't know if this is the exact question in your workbook. I can't remember. Okay, so how do you do this? Okay, so how do you do that? Okay, now let's say they ask you to find, maybe I can even choose to add another level to it, but no problem. So you may be asked to evaluate, say A, f of minus 3, say B, f of half, say C, f of maybe f of, let's say what did I do here? Is this thing greater or less? Sorry, Jesus, what did I write here? Greater or equal to 3. Oh, sorry, the last one. Hey, I was using, sorry, I'm using another example to write here. This thing is minus 3. Minus 3 is less than or equal to x. X is strictly less than 3. Then the other one is x is less than minus 3. X is less than minus 3. Okay, so sorry, that's the distance. Sorry, please. Okay, so let's say that you now have minus 11 over 2, something like this. Okay, so what is going to be the evaluation? Miracle, did you send me question? I will check. Precious sent me private edition. If it's in the group, I'll check the group. Sorry, I'll check it. Okay, so let's look at this. So what do we do here? Can you still hear me? Are you still hearing me? Please confirm. I think you should. Let me check from here. What do we do here? Okay, yeah, you're hearing me. Okay, so let's go on. So for the first one, A is going to be, so what's our function here? Let me get your response. First, second, or third. For A, what's our function? The first one, the second, or the third? So just use first, second, or third to answer me. First, second, or third. First, second, or third. For A, if you want to evaluate at minus 3, what will be our function? The first, the second, or the third? The first, the second, or the third? Who is responding? Okay, beautiful. The second, because our x is minus 3 and minus 3 fell in this range. So our f of x there is going to be x squared minus 3. So f of minus 3 will now be minus 3 squared minus 3, which is equal to 6. Then do the rest. Do the rest. Let me see your solution quickly. Yeah, for my that's okay. So do the rest. Let me see. So no, I sent it here. Integral. Okay, all right. Integral of that. Okay, no problem. We will look at it. Let me write it out. Do I have a pen here? I'm waiting for you people. The two other examples. Yeah, we have gotten A as 6. Steph, we are looking for B and C. B and C. B and C. Response to response. Yeah, Samuel has an answer. Okay. So why do you want to end the class? Dr. Joan, because I'm a human being. I've been a robot, I go to talk like this for almost 6 hours now. The first one we did was about 2 hours. And this one is already more than 1 hour. I'm a human being now. Try. But it's okay. Let's see how far I can still go. I'm not ending now yet. Okay. Yeah, Gift has an answer. Steph has an answer. So I think that B is supposed to be 1 over 4 minus 3. I think that's what you people did that is giving you this, which is 1 over 4 minus 12 over 4. And that is minus 11 over 4. That's correct. That's correct. Beautiful. Go to the next one. Will there be a recorded version of this life? Of course, it is recorded. Yeah, it is. It's recorded. Yeah, so you can come back here later on to watch it again. Then make sure you follow the live section for your own distance in case you have questions. Alright, so I'm waiting for the third one. I think I've gotten one answer for the third one. Angel has an answer. Okay, Angel says 33. Sir, please, number 2. Number 2 from where? Number 2 from where? Good, let me get what your comment is saying. Steph says 33 for C. Okay. 33, okay. Yeah, okay. Me first to Kenkebu first to. Okay, Sam, did you send an answer? I didn't see it. Where is it? Okay, yeah, Sam. Okay, Sam. Okay. Yeah, Sam sent answer 33. Okay. Angelica, Steph. Okay. Ugo, thank you. Gift, that's beautiful. Okay, that's nice. So there's no issue with what do you call it, with what's the name again, with piecewise function. So let's move quickly. Let me start with Miracle's question before going to my phone to get Precious's question. Where is that Miracle? Okay, and that miracles question is from integration by part. So please just be numbering whatever you like. I think I've lost numbering now, so I'll just be writing the questions and be going. So this one now I will use asterisk to just mark my question. So miracles question says integral, I think this my integral sign is too much, integral of x sine of x minus 1 dx. So I think this is integration by parts. Yeah, I think so. Yeah, let's see. Okay, so will substitution do anything here? No. Okay, let's see. So let's do by parts and see what that is going to give us. Okay, Henry Smart, I see your solution. Chisom, good, I see your solution. That's beautiful. Okay, so here now we have x. Let our x be u. So that means our du will be equal to dx. So we'll go a bit faster here. Then our dv will be equal to sine x minus 1 dx. So let me do the v below. So if we integrate here, our v will now be integral of sine is minus cos then x minus 1 all over the integral of x, the derivative of x minus 1, which is 1. So if you divide this by 1, you still get the same thing. So no need doing that. So we'll leave it. Okay. So this is our v. So now let's substitute into our formula, which is uv. Our u is x. Our v is minus cos. So I'm going to bring my minus in front. So put the minus here. So minus cos of x minus 1. Then minus integral of our v, which is minus cos of x minus 1. Then du, which is equal to dx. So miracle, have you seen that this question is really a very simple question? They just put that x minus 1 to stress you. Sleep don't they catch you? Okay, sleep no they catch you. Is it me or Sam or whoever? As for me, I think my eye don't they shake, sha. Then let's be going. So minus times minus is plus, and that is cos into x minus 1. So as I was saying before, Esther, you know these are the kind of questions that you don't used to like. But the thing that you must know is that all this thing is just to stress you small, to know if you understand what you're doing. Because if you understand, this x minus 1 doesn't change anything here. It's just the same thing as using x as 1, just putting x there. It won't change anything. If you put x here, it will still be the same answer. So that's just it. Okay, and then you are done. So this will be minus x cos of x minus 1. Then plus, if you integrate cos, you will get sine, then x minus 1. If you integrate differentiate this, which is still 1, it will still be the same, then plus c, and that will be your answer. I think someone wrote this answer in the WhatsApp group. Okay, so that's the solution to this. All right, now meanwhile, even while we end the class on the channel, that is to grant me some rest. Okay, you can still maybe be sending something on the group. Somebody might respond, or myself too can as well respond. Put water inside your eye. Me, I have juice I'm using to though Lisa bought me juice, although that money no buy the juice, yeah. I completed it and bought juice, so I'm using juice to step it down. Okay, Esther, don't worry. I just want to look for your trouble small. How are you? Okay. So Miracle say yes sir. What if the x is minus? It doesn't change anything. If you change that 1 to 2, all you need to do, go to all the places where you have that minus 1, change it to 2. The answer will be the same because it's a constant. It won't change anything. The derivative will still be 1. Okay, the derivative will still be 1. It's just that most times it's not needed for exam. It's needed though. That's the only way to ask exam question, because you need to make the exam question to be simple. However, in making it simple, you also add some taste of technicality so that it does not just go very simple. If not, we give our exam, this pre-med student 1500, you will see 1000 A. It will be like we don't know what we are doing. Okay, so that's the idea there. Don't worry. The oppression, is it this my small juice that you are calling oppression? See here, smart. If you don't join this channel membership or send me super thank you today, this class end, yeah, here he game when a workbook is 2/30. Think I'm joking with you. Be there and be talking oppression if I sound you. Okay, so let's go on. I think we are done with Miracle's question now. Yeah, Adimchi, you are welcome. This Adimchi looks like a course rep of microbiology. Is that you? If it's you, just let me know. Sparrow himself, you are welcome. Okay, so let me get Precious's question. Precious's question are actually very simple questions on what do you call it, on functions. So let's quickly look at them. Okay, so I think it will just help us review limits of functions very quickly. So the first one says limits. We also did this in class. Limit of sine x over x as s goes to 0. You know, this is L'Hopital's rule. If you put your x as 0, you will get 0 over 0. Okay, so you use L'Hopital's rule. L'Hopital's rule says you should differentiate. If you differentiate sine, you have cos x. You differentiate x, you have 1. So put your x as 0 now. You have cos 0 over 1. Cos 0 is 1 over 1. Your answer is 1. Number 2, he said we should find the limit of, Precious, are you with me now? Limit of 1 minus, okay, let me remove the bracket, 1 minus cos x all over x squared as s goes to 0. I think so. Okay, as s goes to 0. Let me write the third one so that I can come back to the chat group to see what you people are saying there. The next one is integrate x to 0 of f of x, where f of x is tan x minus x all over s cube. Precious, please let me know if these questions I'm writing, if they are correct, because the way you typed it, so that it won't be that I'm representing any question wrongly. Okay, so let's go. So now the second one. Okay, so the second one, it has happened. Okay, see here, this board, no try me. Okay, so let's go. So this second one, if we try direct substitution, if we put x as 0 here, cos 0 is 1, so that will be 0 over 0, which is still L'Hopital's rule. So we differentiate again, and that's going, And if it is exam tomorrow, don't bother writing the limit again and again. Just differentiate. If you differentiate 1, you get 0. Differentiate cos x. Differentiate cos x, you get minus sine x. Okay, all over. if if you differentiate x squared, you get 2x. Now if you substitute your x as 0 again, you will get sine 0. Sine 0 is 0. Here will be 0. That's another L'Hopital's rule. So differentiate. Of course, this is going to be plus. So let me put it that way. So this will be plus sine x. So you differentiate again. That will now give you cos x all over 2. So at this point, you can substitute your x as 0. Cos 0 is 1. And then over 2. So your answer is half. Okay. So help me with number 3. Everyone. Let me see the comments I'm seeing. Okay. Somebody says number 2 is minus half. Sam, is it minus or plus? Okay, village Sibia. Sam, is it minus or plus? See your head. Okay, yeah, Afoma, thank you, Jared. Don't mind that somewhere. If you like, go to that hall and make this mistake and do not come out of this exam with 100 over 100. The slap you will receive, you will not like it. No, be deleting it. Be deleting it. See your head like coconut. Be deleting it. If you like, go to that exam and don't bring 70 over 70 tomorrow. You will see what I'll do to you. You think it's this thing. Go there and make this nonsense mistake. It's slap that you will receive. You will not even go to Okofia, Abi. You will remain here with me. So do number 3, Jare, for me. Number 3. I'm being very serious, so not just to Sam, to everyone. I will call name Esther, Joanne. In fact, Afoma too, I will call your name Miracle, Henry Smart, all of you, Caroline, Precious. Don't go and make mistakes. Steph, I don't want you to come out tomorrow and come and tell me, yes, sir, this one. Don't try it. Don't try it. Don't try it. Okay, yeah, Sparrow. Good to have you. All right, so that's nice. Okay, so who are really ready for this exam? No, you don't ready. Don't say it. You are ready. Just be gathering it small. Okay, answers for number 3. Answers for number 3. Everybody. Answers for number 3. Where am I supposed to? There's also another question he gave us. Okay, another limit actually. Let me also write it down here. Limit of e raised to all these limits he's giving us. I think they are all what do you call it? L'Hopital's rule, as s goes to 0 again. Okay, I think this is also L'Hopital's rule. Then there's another question he gave. He said if the equation of the normal to the curve this is given. I did this question in class the other day now, Chief. I did this question in class. Mind yourself. I will not do it again. Okay. Who is there? Okay, who is there? Nobody has gotten number 3. I don't understand. The topic we are doing now is limits of functions. We are looking at limits of functions. For example, where you never write, wetin concern me? If you like, no write am now. If you like, no write am. And it's smart. Nge this tooth flush that I'm holding now. Nge tomorrow. Be talking now. Who has gotten the answer for I don't understand. Nobody is responding to me again. Okay. In that case, let's quickly look at it together. Should we go together? Please respond. Should we go together? Okay. So as you're responding, let me be going. All right. So first of all, if you substitute x as 0, what is tan 0? Okay, somebody said a bit confused. Okay, no problem. Just do what I'm asking you to do now. What is tan 0? What is tan 0? Okay, where is my second? Okay, tan 0 is 0. Okay, so that means, okay, Pascal says that number 3 is 0. Okay, tan is confusing. Why is it confusing? First of all, remember I said the first thing to do is direct substitution. So if you put directly here, if you put tan 0 here, it does 0 minus 0, which is 0, and 0 cube is 0. So that will be 0. Afoma, don't go to 4. Mind yourself, you have not answered 3, you are going to 4. If I catch you there, don't try me. Don't go to 4. Stay here first. So now, it satisfies L'Hopital's rule. So that means we need to differentiate. So if you differentiate tan, you get sec squared, then minus 1 all over 3x squared. Now you substitute 0 again. Sec 0. So sec is one of the things that will help you is once it is this inverse function, use their normal distance. Sec is 1 over cosine. So 1 over cos x all squared. That's the meaning of sec. So if you substitute x as 0 in cos, that's 1. So 1 over 1 is 1. 1 squared is 1. So that means sec squared of 0 will still be 1. Do you understand it? Without even using Steph, I've answered your question. Without even using calculator, you can get this one. Sec is 1 over cos, and the square of it is the sec squared. Is that clear now? Steph and every other person, let me get your response to that explanation. So this is going to be 1 minus 1, and so which is 0, and if you put 0 here, you still get 0. So that means it is still L'Hopital's rule. Okay, so now we go again. So if we differentiate sec now, so that's where the issue is now. The derivative of sec. What is the derivative of sec squared? Meanwhile, sec squared minus 1 actually represents something. Let me check. You have cos sine squared x plus cos squared x equal to 1. Okay, so if I want to get sec now, I'll divide through by cos. So that's going to give me, if I divide this one by cosine squared, I'm going to get tan squared. This one will be 1. Then this one will be sec squared. Then minus 1. So sec squared minus 1 is actually tan squared x. Tan squared x all over 3x squared. Okay, so as what do you call it? As s goes to 0, okay, So, and of course we already have said that tan 0 is 0, so you can use this. So by the time you now differentiate tan, you'll be getting sec again. So these people are mad. Sorry, let me not bother you people by doing this example. It is going to be a bit long. Okay, so this isn't going to be a good example for this class because it won't be necessary. Okay, so let's go over to number 4. Okay, just clean number 3. Leave that number 4. By the time I finish it, differentiating tan squared x now, all of you will start sleeping. Okay. Okay, so let's move on. Go to number 4. What did you say number 4 gave us? I think Afoma was the first that gave me a response there. No, yeah, Henry, it's not necessary. It won't come out. We can't ask you such question. The first one, the first 2 are okay. Even the third one is also okay. So what did we get for the fourth one? What did we get for the fourth one? Answer. What did we get for the fourth one? That's this one. It's L'Hopital's rule as well. So EX all over 1. So if you put x as 0, 1 over 1, which is equal to 1. Okay, I think that's what Afoma said earlier. Alright, okay, yeah. Froster, Henry, and the rest of you. Okay, so these are some of the few questions I have left from some of you. Okay, yeah. Precious is sending me this same question that we did in class, and I told you that there must have been a kind of error in that question where we were told that the equation of the normal to the curve y equal to x squared at 3 and 9 is 2ky plus x equal to 51. Then k is what? Okay, so, and I told you people that this should have been 57 for you to get a reasonable answer. So it should have been 57. And if that happens, what did I say we should do here? If you people recall, I said that for this kind of example, that all you need to do is to substitute the points and then equate to whatever you have there. So if we substitute 3 and 9 as our x and y, that's going to give us 9 times 2 is 18k, then plus 3 equal to 57. Take this to the other side, you have 18k equal to 57 minus 3 is 54, and if you divide both sides, 54 by 18, you will get 3, and that is your solution, which I think is in the option. But if you check the question, it was carrying 51, and I said in that class that I think it was a mistake. All right, so that's for this. Precious, I believe that answers your question. And for those of you who were not in that class, this is a simple way you can handle questions on normal and tangent. Don't waste your time. They say find equation of normal, equation of tangent at so point. Go to the options, substitute the point to the options you have, anyone that gives you 0, or take, if the equation has something on the left hand, on the right hand side, transfer everything to the left hand side, then substitute the points as your x and y. The one that gives you 0, is the equation you're looking for, and it is that principle that we used here to answer this question. Is there any other question I'm supposed to look at? Is there any other thing? Please kindly respond, everyone. Is there any other thing I'm supposed to touch now before I leave for a moment? Before I leave for a moment. I'm waiting. Is there any other thing I'm supposed to touch? Any other thing? I think someone mentioned conic section or circles are being analytic geometry. Okay. For under analytic geometry, all you're supposed to be looking at is equation of lines, which you have talked about. Slopes, how to get your slope and use the slope to get equation. That's just it. And then combine it with the concept of parallel and perpendicular line. If two lines are parallel, their slopes are the same. If two lines are parallel, then their slopes m1 is equal to -1 all over the other slope. That's all. So you use that. Is your yes, it's still remaining, it's still now 1 liter now, 1 liter. Cheers, exotic. It's still remaining. My stomach don't big self. It's still remaining. Don't worry yourself. So conic section. As a matter of fact, I will only mention circles. Like I said, all other of those conic sections, I'm not even sure they are in our bank self. So don't bother yourself too much there. So for circles, you recall that the standard equation for circle is x minus h all squared plus y minus k all squared equal to r squared. Where? I don't know if I remember again. Yes, equal to r squared. Okay. I will make we no put mine for there. No put mine. No. All other aspects of conic sections, don't bother yourself. Parabola, hyperbola, don't bother yourself there. You may decide to revise what I did with you on ellipse. You may decide to revise it. Okay. But all those other ones, don't bother. But circles, yes. Do circles. Very important. Circles. You may see questions. In fact, we can ask you questions that relate circles and differentiation. There was one I gave you people the other day on one past question I gave you people. Even the people I taught in microbiology, I also gave you people that past question where they said differentiate the function that will be of a circle or the equation of a circle, and they gave you the radius and the center. So what they expect you to do, I think I have that paper here. Let me bring that example. So what they expect you to do is to form the equation and then differentiate it. Let me find it. I think, yes. Where is it? Where is it now? Number 2 here. It says find the y, the x of the circle centered at 3 and 4 with radius 3 units. Now remember that there was another formula I gave you people on circles as well. Sam, can you remember that formula? That's the general formula. X squared plus y squared plus 2 2dx then plus 2ey then plus is f now? I think plus f equal to 0. I think that's the general answer. Equation of circles. That's what I'm showing you now. Mikael, you are here. Okay. Yeah, this one here. I've not even looked at your other name before. Okay, that's what I'm showing here now. Sam, confirm that this. Where are they? Oh yeah, Henry Smart, Amarachukwu, Esther, Kafoma. We are confirmed that this formula is correct. Confirm that this formula is correct. Where our D is equal to what? Sorry, there's no 2 here actually. I think it's in the formula that you will now see the 2. Yes. Where our D is equal to what? Our D is equal to, okay. Okay, but not to bother you to carry all these formulas inside your head too much. You can actually do this thing here inside this place. So just substitute your h as 3 minus 3 squared, then substitute your k as 4, which is this one, then squared, then put your r as 3. 3 squared is 9. If you open this thing, you will have x squared minus 6x plus 9, then plus y squared minus 8y plus 16 equal to beautiful. Samuel, Precious, thank you. That's exactly what I gave. Okay, so equal to 0. So from here you have and then also write what D is. What is your D? D is supposed to be h over minus 2 or so. Okay, D and E. So plus y squared, then minus 6x minus 8x, D is supposed to be minus 2k, minus 2h, and your E is supposed to be minus 2k. Yes, okay. And then your F is supposed to be I think the square root of h squared plus k squared minus r squared, if I am correct. Okay, yeah, so from what Sam just wrote down and what Esther wrote, so if you make from what Sam wrote, if you make D the subject, you get minus 2h, which is what Esther just wrote, and that's what I wrote here as well. Okay, so and that's going to give us F as 9 plus 16. Remember, there is 9 here. I've even forgotten. So this 9 will cancel this 9 here. So you just have plus 16 equal to 0. So that's the equation you are going to Henry Smart, thank you. So that's the equation you are going to now differentiate, so which is going to be implicit. So let's quickly run through that. So if we differentiate this, we are going to have in fact, we can quickly use our implicit formula. Let's use it here. That's dy dx equal to minus fx all over fy, and that is equal to minus our 2x, then this one will turn to 0, minus 6, all of this will turn to 0, all over fy, this one will be 0, then 2y, this one will be 0, then minus 8, and that's all. So our answer here will be, if you bring out minus 2 here, that will be x minus 3 all over 2 here, y minus 4. So this will cancel this, and if you open this bracket, you will now have minus times minus 3 will give you 3, minus times x will give you minus x all over y minus 4 as your dy dx. Okay, Yeah, Sam, thank you. Okay, so that's for circles. So we may also ask you to find radius of a circle, and we'll give you the general equation. It's like I'm becoming too fast. For instance, the one we just did now, x squared plus y squared minus 6x squared, 6x minus 8y plus 16 equal to 0. And we ask you to find the radius and center. So what will you do? You first of all find the center, because you need the center to get the radius using our short formulas. So your center is what they are writing here. H is what we said is minus d over 2. And what is d? D is the coefficient of x, so which is minus 6 over, remember it's minus 6 there, so minus 6, so all over 2, which will be equal to 3. And then your k will be minus e over 2, which is equal to minus 8. Your e is the coefficient of y, and then over 2, which is 4. So that's how you will get this radius, this center that they gave you, which is 3,4. So to get back your radius, we said that radius is the square root of h squared plus k squared minus f. Beautiful. Sir, you are too fast. Oh God, I'm sorry. Oh, Holy Spirit, help me. Let me do small chivita. Oh God. Okay, so sorry about that. It is bad. Okay. The garri you soak don't come off for your body. Sorry, yeah. No vex. Okay, so alright, so I believe everybody is with me at this point. So here now you can now put your h, f, and k. So remember, your f is the one that doesn't have any variable. The one that doesn't have any variable. Okay, I should go down. Okay. The one that doesn't have any variable. So that's 16 in this question. So we have gotten our h and our k. So h is 3, 3 squared is 9, plus k is 4, 4 squared is 16, minus f is 16. So you will have this cancel this. So that is square root of 9, which is equal to 3. And that's exactly the radius that they gave us from the beginning. So I purposely use this example so that you can see how to, is it Michael or Michael? You can see how to juggle with equation of circles in getting your radius, getting your center, and every other thing. I hope that makes some sense. Okay, Miracle is saying minus fx over fy is like a shortcut for implicit. Yes, now. Okay, Miracle Chibo is like you have not always been in our class. Yes, is the sweet short form for implicit differentiation. Let me respond to Stephanie's distance. In this definite integral, when substituting, are we to square them? No. Depending on the function you have, it's true again. Let's take one example on definite integral. Depending on the example you have, you will know whether if the function is squared, then you square when you substitute. For example, look at this. The one you did here, 2x from 1 to 5 dx. This is what we call definite integral. Okay, of course expect to see at least one of these tomorrow or a bit today. Okay, so now look at what we have here. So if you integrate 2x, you get x squared. So when you are now evaluating from 1 to 5, so it is x that you're substituting. So whatever is on top of x, if it's square, if it is times 2, if it is times minus whatever, you would do that. So you put 5, and so since there is square on x, so you square the 5, minus you put 1, you square as well, and your answer will be 24. So depending on what you have, that's what will determine whether you will square or not. I hope that makes sense. Okay, I think it's a good time to stop. It's almost 1 o'clock. So let's stop here. But that doesn't mean our interaction is stopping. So if you have any question at any time, drop it in the group chat. Somebody will respond to you from amongst you. If nobody responds to you, whenever I turn from my bed, I will always check my phone and I will respond to you as well. Alright, where did the x square come from? Abego Chidera, if you say that integral of n is equal to, you add 1 to the power and divide by the new power. Okay, so since what you have here is 2x, so if you integrate, the power of x here is 1, so if you integrate it, you have 2x raised to power 1 plus 1 all over that 1 plus 1. So that's going to give you 2x. 1 plus 1 is 2. That's where the square is coming from. Then all over 2. These 2 will cancel these 2. So you just get only x squared. That's how we got it. Chidera, I want you to respond that you are okay. All right, you're welcome. You're welcome. Okay, so I think it's a good place to stop. If you are able to wake me up around 3, I can still we can still do some other things, or maybe questions on WhatsApp. If you are not in the WhatsApp group, it's a closed group. Actually, it's a paid group, but maybe by the benevolence of my people, we may bring you in just for this night so that you can ask questions, and some of them or some of us can respond to you. All right, so we'll stop here. Please, when I end this this class, as I end the class, whatever, if you are, ensure to like the video. If you did not like, make comments and all that. You can also share the live stream to people at the end of the class. Chris, you're welcome. You're welcome. All right, see you guys later on WhatsApp. Even if we have to meet again on the channel later today, good. If not, on WhatsApp, any question, I would always respond. Bye.